Hello and welcome to my third presentation on my final project titled Financial Charts Data Extraction and Report Generation via Computer Vision. The main point of this update is to talk about the different charts and specifically how am I planning to extract the information from there. So the product specifications and the requirements of it. So here you see all the different types of charts that I will be using, as have been shown in the last presentation from 2 weeks ago. And I will be firstly focusing on the one that's in the middle from crypto.com, as it is the one that contains the most information and it is the cleanest one out there. Once the algorithm works well on that one, I'll be trying it and updating it in order to have it working on every other type of chart. So here are different examples of the chart from crypto.com. All of these are for Bitcoin. And then here I have different time frames, so 24 hours, and I can change it to 7 days, a month, 3 months, etc. And we can see that depending on the day, the prices are different. So the way it will work is the computer vision algorithm will identify the different regions, the different contours available. And from there, I will have a hierarchy of parents and children for all of the contours available in the image. So as an example, the children of a simple image are the images within images. So if I have a square with a circle inside it, the circle is the child and the square is the parent. So I'll be extracting that information once the image has been post-processed by transforming it into grayscale, by applying thresholding, and then from there, with a canny edge detector, I'm extracting all different contours, and with the hierarchy, I can know all of this information of where I have my children and where are the parents and the relations between them. And from there, I will pass all of that information into a convolutional neural network or an ensemble of convolutional neural networks. And I'll have two methods for that. So the first method is to extract information from the different contours, so features pretty much. So for example, for the axis here, the different features would be if there is a straight line, if there are many parallel lines close to each other, if there are numbers present, if there is a name at the top of the axis. So this could be price or time or the name of the currency itself.
I can hear you.
The second type of method is for me to pretty much pass all the different pixels and everything into the convolutional neural network. And then from there, let the convolutional neural network understand the difference between, for example, the y-axis or the x-axis or the price. So here you can see how the second method would work. I would apply a kernel to simplify the processing, and I will learn all of these different values, all of these different informations. The convolutional neural network will learn them so that it will be able to specifically differentiate between one type of contour and another type of contour. So here's an example of an ensemble of convolutional neural networks, and this is most probably the type of solution that I'll be employing, as this can increase the accuracy of my system, as I'll be having two different neural networks that are trained on specific information, and that will increase the overall accuracy once I have an average ensemble output. And then for the value extraction of the curve, what I'm going to do is I'm going to identify the curve, and I'm going to use canny edge detector to get that array of pixels, as can be seen on the right side in the little square. And then I'm going to transform that into an array that's one-dimensional. And from there, I'll be able to get the coordinates of the different values, because I'll have the value and the coordinates together in the same element indexed to the same position for all the different pixels that will be in this one-dimensional array. So I'll be able to get the highest X and Y coordinates, which means that that's the highest price. And if I get the lowest X and Y coordinates, that means I'm going to get the lowest price. And That, of course, is dependent on the time frame. And then I can calculate the distance in pixels between the highest x and y or the lowest x and y, and a frame border or the x-axis, a point of reference pretty much, and then calculate the exact same distance on the y-axis. So for example, if from 0 to 1, I have 5 pixels, right? That means that every pixel is 0.2. And then if the separation between all the different values on the left side and the y-axis is equal, that means that every 5 pixels I have 1 and every pixel is 0.2 for the whole length of the y-axis. So then I can calculate the exact same distance from the frame border to that point, which represents the distance of x and y, and get the exact price of my currency, and get the highest price and the lowest price and the current price, and then put all of that into a data set that will then be outputted and then can be used with different other systems. And this information from the data set will also be used for my report generation. That's automatic. So I'll be having insights that will tell me how the prices have increased by a certain amount, of how they increased by another amount. And it will just pretty much automatically generate a sample office document that pretty much has a summary of the most important bits of all the changes in the last 24 hours or 48 hours, depending on how it's been set up and scheduled to run. And then I'm also planning on having software testing in my program, as it is very important to have all of the different modules working correctly. So most probably I will be implementing a testing framework with unit testing, both through methods and its functionality. And I will see exactly, I'll make sure that pretty much the program, when it's being run, it follows the requirements and the documentation for a correct output. And with all this said, this has been my update in my third presentation for the requirements and the outputs that I'm expecting from my program, as well as the way I plan on actually reaching those requirements and how I plan to have my code structured. Thank you.